What is up, guys? Welcome back to Core CSS Mastery. We're going to be talking about color theory. Now, one of the theories I have about color is that it should be spelled with a U, so it's C-O-L-O-U-R. But we're going to deliberately typo this. You've probably seen this already throughout the entire course, and that's because in CSS, it's spelled C-O-L-O-R. There's no U, so we're forced to use the American spelling, which is fine, but when I also use the word color in a PowerPoint slide, for example, I'm also going to deliberately misspell it so it ties in with what we're doing with CSS. In the early stages of learning any language, whether it's CSS or PHP or JavaScript or Python, our initial steps are usually just to try and get stuff that works. We're not necessarily focused on the overall picture, we're just happy if our code works. Then when we get the facility where we can do anything we want with our code, so in the case of CSS, imagine we could do absolutely anything. All of the features of CSS are available to us. We start needing to think more carefully about what makes the most sense, not just being happy with anything that actually works. In this lesson, we're going to talk about the theory behind using colors. We're not necessarily going to focus on CSS itself. We're thinking about the web design element here. What are good colors to use when creating a website? Now, checking out the W3 docs, we're introduced to the concept of a color wheel. And on a really simple level, we can see a color wheel is colors organized around a circle in a specific way. Now, there are three important color wheels. There's the RGB color wheel, the cyan, magenta, and yellow color wheel, and the red, yellow, blue color wheel. Now, we've already seen usage of RGB, and we know it stands for red, green, and blue. We even have a CSS function that allows us to define the pigmentation of red, green, and blue to result in the final color. Now, if we have a look at the RGB color wheel, there are some interesting assumptions here. For example, it says red and green makes yellow. Now, if you think about that from your experience as a regular person outside of the realms of using computers, if we were to take red and green and mix them together, do we end up with yellow? And hopefully for most of us, the answer is no. If we mix red and green together, we actually get some kind of murky brown color. Whereas here it clearly says red and green equals yellow. Now, the reason for this is there are two different ways that colors can mix. There's additive color mixing and subtractive color mixing. Now, when we look at colors on a screen, which are comprised of red, green, and blue, this is a type of additive color mixing. So we start off from black, we add the light source of one color, for example, red, and we add a second light source, green, and mix them together. Now the result here is an even lighter color because we're actually mixing two light sources together, so we actually end up with yellow as a result. Now, as regular humans that perhaps don't spend our entire life on the computer, when we think about mixing colors, we're probably thinking about mixing paint together on a piece of paper. And we know if we do that and we mix red and green, we're going to get brown, not yellow. And that's because this is a type of subtractive color mixing. Unlike additive color mixing, where we start from dark and gradually add additional light sources, subtractive color mixing works in the opposite way. You see, in front of us, we usually have a white piece of paper. And what a white piece of paper means is that all of the light is being reflected back to us from that piece of paper. And as we begin to add colors, we reduce what's reflected back to us from that piece of paper, and hence we see colors. And naturally, the more colors we add, the more we're reducing the light being reflected back to us, the darker the color we get. So you can see, depending on whether we're using additive, so in the case of colors on the screen, or subtractive, as in the case of paint on a piece of paper, different color combinations are going to result in different final colors. Now, there's a third set of three colors in the mix, and that's the cyan, magenta, yellow color wheel. And we usually associate that with printing. And obviously that's a type of subtractive color mixing because we're seeing the end result printed on a piece of paper. So why do we have two color wheels that deal with this subtractive type of color mixing? Well, the simplest explanation is that when you're learning art at school in class, it's going to be fairly complicated if your teacher tells you the three primary colors are cyan, magenta, and yellow. Hopefully you can see the similarity between cyan and blue, magenta and red, and obviously yellow is the same color here. But the ideal version of this color circle is actually cyan, magenta, and yellow, not red, yellow, and blue. Having said that, if you do take any kind of art class, not that I have, which is the disclaimer here, you're going to be told very likely that the three primary colors are red, yellow, and blue, not cyan, magenta, and yellow. We don't really associate those with paint colors, we associate them with printer colors. So hopefully we understand a little bit about what these color wheels are. In fact, it was actually Isaac Newton who first developed the theory that all colors are mixtures of red, green, and blue light. And we can see the first known color circle, which was actually created in 1666. And the important thing about this color wheel is where the various colors are relative to each other. Because it's this that's going to help us to design a compelling color scheme. There are a few different ways of going about this. Let's start off with the most basic, which is a monochromatic color scheme. And you can see here on the W3 docs, we have a try it yourself option where we can choose a color from the wheel and generate a monochromatic color scheme. Now, monochromatic just means one color. So you can see an example of that. We have a sample web page here, and it uses several different colors of green, but essentially it's all the same color. If you think back to the hue, saturation, and lightness model, well, imagine we keep the hue the same, but just play around with the saturation and the lightness. We actually get colors which are essentially the same color, they're just different shades of that color, and these are all going to fit together. So that's why we can refer to it as monochromatic, even though as you look at this, it actually has different shades of green, which are technically different colors, but the hue value of those colors is the same. Now, the cool thing is we could actually come here and use something like this try it yourself color wheel to get some ideas for monochromatic themes. So for example, let's try blue. And we can play around with the lightness and the saturation. So if we dial down the saturation, we can see more of a gray tint coming through. If we dial up the saturation, we get more of a vivid blue color coming through. We also have our lightness. That's obviously slightly more washed out. If we boost the lightness, we bring the lightness down, getting more of a very dark overall color scheme. Now, not every color scheme is going to work perfectly. This doesn't look like an especially nice color scheme. We've actually maximized the saturation, but turned down the darkness as far as it will go. So that's probably not going to result in the best overall visual experience. But you can see most of the color schemes in the middle look visually pleasing, and it doesn't matter too much which color scheme we pick. We're actually getting some fairly nice results. So it might be a good idea to stay away from very extreme values, but I would say that a high percentage of these color schemes would actually work in a production environment. Now, let's say we play around with these colors, we find a theme that makes sense for the website we're trying to generate. As you can see, we have a list of hex codes generated for us. So we could actually just take these hex codes and put them as part of our CSS. Now, there is a whole psychology aspect to this as well, and I encourage you to look into that just to give you some examples of color psychology. It says green is the most restful color, so I guess that would be useful for eco or nature-based projects. Blue is the most used office color. Yellow is a happy color. Black is authority and mystery. Gray is conservative. Really big companies are very likely going to have their own branding expert that will deal with this type of thing. But certainly for smaller projects or for our own personal projects, it's good to think about the psychology behind the color scheme we choose. Now, referring to our different types of themes, similar to monochromatic, we can use colors which are not exactly the same hue, but still close to each other on the color wheel. So you can see here's an example. We have a teal type color, we have a green color, and we have a greeny yellow type color. And you can see the end result is a theme that still looks quite pleasing, even though it's not monochromatic. And once again, we have the option to try out different themes. And this is not to say that all of these themes are going to be good. The end result is going to be somewhat subjective. And similar to the other color finder, we can actually play around with the saturation and lightness to get that perfect color. But the end result here is still going to be a color scheme that's better than colors picked randomly. You can see there's a thought process here. We have an awareness of the color wheel. Monochromatic, we're picking colors with the same hue, with different lightness and saturation. And here for analogous color theme, as it's described, we have colors that don't have identical hues, but their hues are taken from a close proximity on the color wheel. So we can play around with this, we can find a color theme. It's always a good idea to try and do things this way, where we decide on a possible color scheme. Then when we get around to writing our CSS, we'll know exactly what we're looking to implement. Whereas from that mentality of just trying to get stuff working, the temptation can be to jump straight in with the CSS and try out different color schemes without consulting a color wheel, without thinking about branding, without thinking about the psychology of different color themes. And we end up with something that might not be as streamlined in the way it looks than a color scheme where we've deliberately thought about it beforehand before we even write our first line of CSS. CSS is a tool, not necessarily the main objective. Now, by far the most interesting color scheme for me is the next one, which is complementary colors. And this might seem counterintuitive at first. Complementary means deliberately picking colors from opposite sides of the color wheel. Now, it might sound like it shouldn't work. Shouldn't these colors be so different from their corresponding color on the other side of the wheel that we get some very strange looking themes? And yet we end up with some results that end up looking really good. And the best way I have of explaining this is when we have colors from complete opposite ends of the wheel, those colors really pop because they contrast against each other. So we're looking for one of two things here, either colors that are very similar, so they complement each other in that sense, or we're looking for colors that are extremely contrasting, opposite ends of the spectrum that then pop against each other and make a very vibrant color theme. If we were instead to perhaps take two colors that were at right angles, 90 degrees from each other, we're not going to get the benefit of either world. We're not going to get those colors that pop against each other, and we're not going to get those colors that complement each other because they are a similar hue. We're just going to get something that's in the middle. Now, once again, this is subjective. This is not to say that other ways of producing color schemes don't work, but on a basic level, in most cases, we either want to choose colors that are located at a similar location on the wheel, or we want to choose a color scheme that involves colors from the opposite ends of the wheel. Now, just to check out some of the other color schemes that are recommended here in the W3 docs. So this is the triadic color scheme. Triadic schemes are made up of hues equally spaced around the color wheel. So based on what we've just said, we might feel that this shouldn't really work in theory, but you could find that you get some fairly good results. And certainly some of these color schemes look at least okay, and we can play around with them and find something that looks great for us. I am kind of feeling more of the complementary or analogous themes at this stage. We then have compound. So what we're doing here is essentially using colors from the opposite side of the color circle, but on one side you can see you're actually making use of two colors that have a similar hue. So this is really a cross between the complementary from opposite sides of the circle and analogous, where we choose colors from the same side of the circle with similar hues. So that's pretty much it for color theory. Key takeaway here is before writing your first line of CSS when styling a web page, take some time to play around with color schemes, play around with color wheels, decide if you want colors from the same side of the circle or colors from the opposite side of the circle. Pick a theme, think about the psychology of that theme, think about the branding and what we're trying to accomplish. Make a decision on a possible color scheme. And by the time we write our first line of CSS, we'll already have a very good idea of what we're trying to achieve with the color scheme of our site. Thanks very much for watching, guys. Catch you in the next part of the course.